So I got good news and bad news. Any questions before I do the good news, bad news? Bad news, these problems are a pain in the butt. I mean, potentially you do the problem, you get to the end over here and you go, oh, it's moving, so then you have to redo the problem. Or you're given this and you're gonna go, all right, it's not moving or it is moving. Let me just go for it. Let's just assume it's already moving. Let's just skip this step right here. We'll check to see if it's moving or not and just assume it's already moving. And it's a flip of the coin. So the bad news is these problems can be a pain in the butt because you potentially are working through it twice. The good news, as a student, I hated these problems. I'm not saying I've never done a problem like this on a test. I'm just saying that when I do it, I think twice before I go, yeah, I'm gonna do this. So, any questions before we do the book and cup problem? Because you are ready. The other good news is you can solve this kind of problem. Because you have seen it once and therefore you are experts. Because that's the way education works. I still go through the same steps. We'll just need a more complicated problem here. By the way, as you're doing these problems on a master set or looking at an old test and doing the problems, first thing that I'm going to be looking for is where are you? Have you done the force diagram yet? Have you done this? Which of these parts where are you in the process? If you're struggling with a force diagram, that's a different problem than you made a stupid math error down at the bottom. Stupid or silly math error, whichever way it happened. Let's make this a 37-degree angle. We'll stick a pulley there, an ideal pulley. We'll have a rope here, and attached to this is a book. The initial velocity is up the ramp at 10 meters per second. And down here we have a cup attached to the string. So the problem starts, the book is already moving up the ramp, the cup's going with it. It's an ideal rope and pulley so that as the book moves, the cup moves with it. Mass of book is 7 kilograms. Mass of the cup we'll make it 2 kilograms. It's a really heavy cup, or massive cup. So the question is, how far up the ramp will the book slide, and will it slide back down? We'll make mu sub s equal to 0.4 and mu sub k equal to 0.2. Anyone need clarification on what the problem is? Well, it is moving up.
Oh, okay.
So they're sliding like this. If I got my coordination correct, that hand's going this way, this way. So they're sliding like that. It slows down as it goes, it'll stop. And then the question is, so how far up the ramp does it go as it's sliding? And then will it then slide back down? moment for people to finish writing. All right. What's the first thing we do? Now, we could do the complete force diagram. Really, I only care about the cup and the book. So all I'm going to do is just book right here and cup right here. So what are the forces acting on them?
Is there another for the book?
No, because it's already moving when we started the problem.
Okay.
What got it moving, we don't know, and it doesn't matter. Motion has no memory.
Weight.
Okay. Weight of book, so W sub B. And the other part of that pair is acting on the ground, which is not on the diagram at the moment.
Weight on the cup.
Okay. So if we're doing F tongue, so we've got gravitational force taken care of.
Normal force on the book.
Going which way?
Oh, I don't know.
It's perpendicular to, it is perpendicular to the ramp. Again, normal to the ramp.
Can we cross out the other?
And cross out other.
And
All right, and in that direction. So Martina, you were close. It was just the force that you pointed in, the one going that way is acting on the ramp, which I don't have in the diagram right now. But it's the ramp that's holding, keeping it from falling in direct free fall. So we have this normal force right there. I guess that's it for normal force.
Friction.
Which way is friction acting on what? Which way is it on the book? Which way is it acting on the book?
Going down.
Okay, so we have friction acting back this way. It's kinetic friction specifically, because we know the book's already moving. And that's, pardon?
not the cup.
Oh, no, no, no.
Wood, the cup's not rubbing against anything.
There's tension force.
Acting which way on what?
Describe the direction.
Up on the cup, right?
Up on the cup, okay, we got that one.
Also be on the book.
It'd be up.
And which way on the book? Yeah, down the ramp. Is that what you said? No. You could have walked your way. Just so you know, the camera here is very bad about picking up sounds behind it. So you could have walked your way through that one. There's no real recorded evidence for it. All right, so we are done. Those are all the forces acting on those two objects. Obviously, it's not the full force diagram, but these are the two that we care about. What is the acceleration? So force diagram. Sorry, what's next?
Acceleration.
Okay, which way is the box accelerating?
Up to the
If it were accelerating up and to the right, what would the box be doing? In other words, if the acceleration and velocity were in the same direction, it would be. Is the box, based on your personal experience of things going up a ramp, do they tend to speed up?
No.
All right, so it's slowing down. So which way is the acceleration?
down.
So acceleration is that way. And what about for the cup? Which way is the cup accelerating?
Straight down.
In the past, the object was going to move in the same direction as the acceleration, so coming up with a coordinate system was relatively simple. In this case, you have a decision to make. It depends upon whether you want acceleration to be a positive or negative number. If you choose the coordinate axis to be up the ramp, then I would expect acceleration to be a negative number. If you choose it down the ramp, I expect acceleration to be a positive number. And it doesn't matter which one you pick, as long as you're consistent. Up the ramp or down the ramp for my coordinate axis?
Down there.
So we are establishing for this one, coordinate system like that and that. I'm gonna call this IB hat and JB hat. And for this one, down, I'll make this my IC hat. Those are right angle to each other. What next? Do we have to break up any of the vectors?
Yeah.
No people saying no and someone says yes, so
Yeah.
why, what are we breaking up?
Don't wait.
Why?
Isn't that actually?
It's not following the, it's going straight down and the I hat's not straight down.
For that mass. Since we're talking about the weight of the book and it doesn't follow along the lines of either of these. It is in the same direction as IC, but that's a different coordinate system, different object. All right, so we have weight, and we've already broken it up several times. Or I guess we went through the long way once, but we're gonna take that. We have tension acting down the ramp, we have friction acting down the ramp, and then we have WB sine theta acting down the ramp. Into the ramp, we have WB cosine theta and normal force acting away. So breaking the weight up just as we have done. Now we're ready for the equations of motion. How many equations will there be? 3. All right. So we'll have an IB hat, JB hat, and IC hat. All right. So, someone who hasn't chimed in yet, let's give an opportunity for someone to take a shot. Someone new to take a shot. In the immortal words of the Frizz, take chances, make mistakes, get messy. All right, what I'm gonna do is I'm gonna randomly call on someone. I apologize if you're painfully shy. That might be someone who already chimes in, so let's go to the page. I'm gonna close my eyes and just put my finger down. 151, make sure I'm on the right class. It's pointing at one of 2 people here, so Vincetti or Efren? I think I've heard Vincetti more than Efren today. So Efren.
Okay, y minus WB cosine theta equals NA, yeah, mass. 0.
Yeah, it is 0. Why is it 0? Other than the fact that I just looked at you strangely when you said A.
Because it's not.
There's no acceleration direction.
Right. The acceleration is, we established acceleration is down the ramp,
Mm-hmm.
which means there's none perpendicular to it. So, and since you did that equation,
Wouldn't that be G?
that is the J equation. All right. Oh, anyone whose voice I have not heard, or am I going to do the finger again? Nope, wrong page. Who do we have here? It's pointing between Keelan and Sophie, and I've heard Keelan, so Sophie, give it a shot.
Okay, so f of t plus, f of k plus, w's b times sine theta equals na.
Okay, there's a small little mistake there, but we'll put it on pause for right now. I've seen students make the same small mistake, but when by the time they get to the end of the problem, they've corrected it. So it's just a matter of, well, let me just open it up right now. Anyone see the small little mistake? Efren did the same thing, but it's less of an issue in his case.
Is it W?
No. You don't like the way I make my W? There's nothing wrong with W.
Don't we know the value of mass?
Pardon?
Don't we know the value of mass?
Did I give it to you? We did. Are you suggesting we stick in numbers right now?
Well, you did for acceleration cells.
Oh, I think that's a little bit different in that case.
Is it the FK?
No, not an issue with FK. All right, it's not critical yet that we solve it, but we'll come back to it. All right, so one more equation. Do I have a new voice? Someone willing to take a shot at this, or am I doing the finger again? That is pointing at Haley.
She's not here.
Should we call her up? Ben and Vincetti, one of you two. I think I've heard Ben more than I've heard Vincetti. All right, so Vincetti.
Oh. I'm trying to look at this. Is it y equals?
We're doing the IC hat. We're doing the one for down here.
FT minus YC?
There's no Y there.
I mean WC.
What's WC?
I don't know where to go from there.
Pardon?
I don't know where to go from there.
Have you done all the forces? We're plugging into F equals MA. Once you've accounted for all the forces in that direction, then you get to the equals. I hope it's not zero. I guess we do have a tag team there. All right, there's a, yes?
Did we swap WC?
Yeah.
Is that what?
We said down being positive. So that would be negative and that's
Is
positive.
that what's wrong?
Oh, okay.
That is not, no, there's nothing wrong with the signs in the other one. All right, we have the same issue here as we had in the previous one. Anyone see what the mistake is?
Plus and plus?
Pardon?
Plus and plus, this should be negative, I mean minus?
No, the signs are all correct right now.
Maybe there's two positives, so one is being negative.
No, this is in the negative direction, that's in the positive direction. Up here, all three of these are in the positive direction. That's in the positive direction, that's in the negative direction. So we're good on all that. Accelerations, we made it so the accelerations are in the positive direction, so we're good there.
Where's our gravity, RG?
Or that's coming into the substitution phase.
IDK.
All right, let's do substitution. After the substitution, we definitely need to fix the problem before we get to solve. All right, so we now have, we have a formula. What do we have a formula for? Or for the grammar Nazis? For what do we have a formula?
Wait.
And,
Equals admission.
okay, and what's the other? Yes, what's the formula for this friction? Should be in your head somewhere. Or if you don't take notes, in your mind. So we have W equals mg, that's one of the formulas, and then kinetic friction is equal to
The weird letter, the mu, or whatever you call
mu,
it.
mu.
Yeah, NUK times Y.
So UK1. All right, so we do the plug-in, so I get Y equals mg cosine theta. I have tension plus mu ky plus mg sine theta equals ma. And I'm gonna flip the order down, round down there. So mg minus tension equals ma. I just made the problem a little bit worse than it was before, but it's still easy to fix. It's not, we're not gonna have to rewrite anything. But we do need to make a change. Anyone see what the problem is yet? Yes?
The Y in the second equation should be mg cosine theta.
Oh,
Yeah.
that's, that will come into the solving phase.
Okay.
Is it FK
Nope.
Y?
Pardon?
Are we missing the Y on FK?
No, right there.
No, I'm talking about the first I.
But this is the second equation, this FK right here. The Y doesn't show up till we do the substitution. Am I missing what you're asking?
No.
See? Okay. I didn't know if that was one of frustration because I'm not understanding, or frustration if you just realized what your mistake was.
No, I'm just trying to figure it out.
Okay.
One of them doesn't equal zero.
Pardon?
One of them doesn't equal zero.
Oh, this was equal to 0 here, and I just added that to both sides. So I sort of skipped 2 steps, or skipped a step. Combined 2 steps, that's probably better wording. All right, a hint is that I made the problem worse when I did my substitution.
You won't be able to divide by mass.
What, this by mass?
Yeah. You won't be able to get rid of all the masses because of the tension.
Yeah, that's not an issue, it's just, well, eventually we'll add these 2 equations together and get rid of the tension. Or solve for tension and plug into the other one. Not an inherent problem.
Can you give us a hint?
Another one? If it is not readily obvious which equation goes with which object.
Are we missing subscripts on the tension?
No, not on the tension.
The mass.
Yes. This mass and this mass are not the same. This weight and this weight are not the same. You need to differentiate. This mass right here, this is the mass of the book, mass of the book, mass of the cup. So this weight right here, this WB is M sub BG, MBG, MDA, MC, MC. They are not the same mass, and therefore we do need different subscripts. Now we're going to solve for acceleration. We have this that we can substitute in for y. And so let's just go ahead and do that. So I have ft, so taking those 2 equations, ft plus mu k mdg cosine theta plus mdg sine theta equals mdA. And then our other equation, I'm just going to write it. So mcg minus the tension equals mca. We're trying to solve for acceleration. I have 2 unknowns here. I don't know the acceleration and I don't know tension. Those are my 2 unknowns. But we're in luck, we have two equations, two unknowns, generally solvable, as long as they're independent. So we need to somehow combine them. I can solve for tension in one equation, plug into the other, or I can just add them together, which is convenient in a case like this. Because I have positive tension here, negative tension here, they will cancel out if I just add the two equations. So I end up with, make sure I have enough room here. I have mcg plus mu k mbg cosine theta plus mbg sine theta equals mba plus mca. No, sorry, Isabel, are you able to see this okay?
Yeah, that color's good.
Now, I can't cancel anything out. I don't have the same factor in every problem. I have mass in every problem, in every term, but they're two different masses. I'm solving for acceleration here, so let's get acceleration all by itself. So I have mb plus mc times a. And now I divide to get a by itself. So I have a formula for acceleration, and since they won't give me a board that's raised, I will have to send. Acceleration is mcg plus mu k mbg cosine theta plus, see if I can pretend to write neatly, theta plus mbg sine theta divided by mb plus mc. And let's make the mu look more like a mu. And that k more like a subscript. And now it's a plug and chug problem. So we have 2 times 9.8 plus 0.2 times 7 times 9.8 times the cosine of 37 degrees plus 7 times 9.8 times the sine of 37 degrees divided by 7 plus 2. And that marker, this one, those are separate. Wow. For the video camera, I nailed that right into the trash can. All right, so let's see. That is 19.6. That marker is also sad. $19.6 plus 1.3 something. So 7 times 9.8 is 68.6. So 1.372, I believe. Ish. I'll just make 1.37 plus oh, wait, I forgot to multiply times 0.6. So
Sloped masses.
Slotted masses should be,
Yeah, oh, behind here.
That's my, oh, what's this?
I have a final answer if you're interested.
pardon?
I have a final answer if you're interested,
Okay,
but I don't know if it's right.
go for it.
6.889 meters per second squared.
6.889 meters per second squared. Anyone else got that?
Okay, 7.98.
What'd you get?
7.98.
Anyone else?
6.94.
Place your bets.
I got 6.88.
So we got 2 for that. Let's go bit by bit. All right, so that right there is 19.6. This right here, I'll go ahead and do the denominator and handle that, 9.
That bit is 10.96. The second
This one right here, 10.9,
96, yeah.
10.96. Okay.
And the last one is 41.28.
And so it gives a 4, carry the 1, gives us
Yeah. 7.98.
7.98.
42, 52, 71.81.
Yeah, that's what I got.
Yeah, it's 7.98.
So it's 7.98.
Yes,
Who's right?
sir.
So 2 people made the exact same mistake. Or you ended up with the same answer. And I've seen that before. Just keep that in mind when you're doing labs. Just because somebody says an answer with confidence doesn't mean they're right. All right, so 7.98 meters per second squared. Let's make sure we got the units in there. And that's just a straight mark right there, so that's 7.98. Questions to hear? We've done the hardest part of the problem. We haven't